thank you very much for your time today, for joining us to talk about the importance of the safety around end-of-life vehicles, and also looking at the importance of when we dismantle a vehicle, and especially with electric vehicles as well. So thank you very much for your time. We've got some great speakers. We've got Andy Latham, who's the CEO of Salvage, and Mark Jones, who's the founder of ELV Training. These guys have got lots of experience. I know personally Andy has traveled the world advocating and sharing his experience and training people on the importance of how to be safe around electric vehicles. And Mark has a great wealth of knowledge when it comes to dismantling recycled vehicles, end-of-life vehicles. Sorry about that. So yeah, so look, let's introduce, I've done the introductions. My name is Haydn Davies. I'm the editor of Auto Recycling World. And I've just sort of talk and bring the community together for everybody. I'm rambling, so let's move on. Who's the first to speak? Mark. Okay.
I believe that's me.
Okay, Mark, the floor is yours.
Okay, thank you. So I'm just going to put my presentation up here, and then we'll get going. Too many buttons to press. Here you go. Can everyone see the presentation?
Yeah, that's fine.
Great. So, no surprise, I'm here to talk about processing end-of-life vehicles. I suppose when we were invited to come and do this webinar with people, with the health and safety and environmental professionals, people have a really good understanding about when they purchase a car, how it's made, and all the bits of the sector around vehicle ownership. But sadly, at the end of the life, when a vehicle is no longer viable for repair, and we look to unload that vehicle, it's either traded in for a newer vehicle, sold privately, or it's collected by an insurance company. So the majority of the public do not come into contact with automotive recycling operators, and therefore it's a bit of a dark art. The majority of the public do have no exposure to what's involved in auto recycling. So I guess my precursor to talking about the challenges that we face in the sector would be is to make sure that we do kind of a little bit of baseline here and make sure everyone has an overview of the industry worldwide, and obviously UK based, which is where I'm based. There's about 40 million vehicles that reach the end of their useful life across the globe every year, and just over half of those are recycled. So we've still got a long way to go on that journey and building that circular economy. And this is an overview of some of the examples, I'd say the comparable countries that we would look to gauge our recycling performance against would be people in the Western world, such as European Union, the States and Canada. Don't worry, there won't be a test on this later. How big's the UK industry? Well, we have about 41 million vehicles on the road, and about 38 million of those are cars and vans. And I make the distinction from cars and vans purely and simply not because they're just private transport, but because these fall under what we refer to as ELV regulations. So legislation that was brought in to govern how we decommission the vehicles in a safe and environmental way at the end of their life. This is just showing you a snapshot of industry data in the UK, which in fairness is not dissimilar to what the trends that we're seeing in other Western countries. The average age of a vehicle when it comes to the end of its life is around 14 years. That could be because of age, that could be because of reliability, uneconomical repairs, or obviously collision damage insurance write-offs, etc. Over half of the vehicles currently that are on the road are UK, and I only did this data a couple of weeks ago, so it's absolutely bang up to date. half the vehicles on the road are 10 years old or older. So yeah, about 40 million vehicles on the road, and 20.4 million of them are already reaching the end of their lives. As far as depollution capacity in the country, we have about 1,900 what we refer to as ATFs, authorised treatment facilities, which are permitted sites. So they carry an environmental permit and they're allowed to legally depollute these vehicles and dismantle them at the end of their lives. The number of vehicles that are on our road grow year by year. There's been a 1.4% increase over the last year. That, for us, as far as older vehicles, is probably about 3 million vehicle increase in cars and vans alone. So pretty sizable. We depollute about 1 million vehicles a year in this country. So there's a disparity straight away from the industry data in the fact that we are not depolluting enough. And there's a few reasons for that that we're not going into, but it's not from a performance point of view. It's more to do with the fact that depollution is becoming a very much more involved process, not just because of electric vehicles, but more to do with the fact that vehicles, more modern vehicles, are more recyclable. And because they're more recyclable, that depollution and dismantling process becomes more intensive. But the takeaways for us here are that no one size fits all for our business. There are various business models at play. Everything from a multinational metal recycling business, where vehicle recycling might only be a part of a series of core operational activities, all the way down to a single family owned regional metal scrapyard merchant and everything in between. We have large vehicle salvage breakers, which have capacity to process 2,500 vehicles. We have used car parts, green parts, people who specialise in certain makes and models of vehicles. Then we have the repairable motor salvage auctions, car scrappage schemes, car collection services. So the recycling sector from an automotive point of view is very diverse, and consequently from our point of view, a training point of view in my business, we spend a lot of time with different profiles of business, different business models, in trying to understand how we can best meet their training requirements. So I thought I would assume no prior knowledge here, so apologies if this is all rudimentary to a lot of our viewers, but this is a typical end-of-life vehicle journey. This is our process, and I thought it would be good just to baseline everybody's knowledge. When we talk about end-of-life vehicles, it's the vehicles that get scrapped, the ones at the end of their life that get dismantled and repurposed or recycled for their raw materials. And across the world at the moment, we recycle about 25% of the metals that we use in new vehicle manufacture is 25% of it is recyclable. So again, lots of room for improvement there, but we're moving in the right direction. As I've already alluded to, legislation governs the blue bit in this diagram, the depollution and the dismantling aspect of it. And this is the part where we remove all the hazardous materials from the vehicle in an environmental way. So that'll be the waste oils, gearbox oil, fuel, batteries, coolants, antifreeze, screen wash, air conditioning, refrigerant, the tyres, even the pyrotechnics that activate the airbags and the pretensioners. Everything that's hazardous to that vehicle needs to be removed before we can then further process that vehicle. And as much as the vehicle recycling process is very much automated these days, this blue bit here cannot be engineered out. We rely on people to do this. And that is where risk and inefficiency lies. Because once material leaves depollution, dismantling, and moves on to the shredder and the post-shredder technologies, it's pretty much automated from there on in. It doesn't involve human interaction, that sort of stuff. So after depollution, we have dismantling. and the vehicle's residual parts can then be removed, sold on, or what's left of the vehicle's carcass then can be put into the shredder and the raw materials extracted. Not every vehicle gets fully dismantled, so even though depollution has to happen for every vehicle to remove its hazardous contents, some vehicles that their parts are not worth anything, or there's no demand for those parts, they will simply be depolluted, baled, and then inevitably end up in the shredder. So that is a real quick kind of overview of what we do and how we do it. But for my discussion today, I'll be talking about traditional end-of-life vehicle depollution and dismantling, specifically around internal combustion engines. And then I'll be handing over to Andy, and Andy will be talking in more detail about the risks associated by introducing electrification into our activities. So this is a typical depollution station that you'll see in a modern facility these days. They vary in size, capacity, but technically they are a frame and then a piece of equipment there that's designed to specifically remove the hazardous materials, fluids and components from a vehicle in an efficient manner. Now, before we go into a depollution station, the airbag and the pretensioners have to be detonated, so we use special equipment to do that, and it's done outside to control the risk. We'll also remove the 12-volt battery, wheels, tyres, the lead weights from the batteries, and obviously any tyre pressure monitoring systems, because they have lithium-ion batteries in them. That all gets taken away, and then the vehicle, via a piece of plant equipment, usually a counterbalance forklift truck, will then, or a telehandler, the vehicle will be moved into a depollution rig, one like which is illustrated in these diagrams. Most of this equipment is designed for fluid evacuation under vacuum, and that is done because it's a relatively manual task, and it's to speed up recovery times. Hazardous waste is then pumped to a bunded area which is outside of the depollution area, and it's outside the depollution area because we have explosive atmospheres to consider here with extraction of fuel, so that has to sit outside the desire zone. We may also have hydraulic shears to actually remove the catalytic converter, which we know is full of precious materials, away from the rest of the exhaust system. And then we'll take all the other fluids and everything off the vehicle. Once this has happened, the vehicle can then safely, once it's had all the hazardous materials removed, it can be deconstructed. But what we're finding, as vehicles are becoming more recyclable, and the vehicle manufacturers are spending a lot more time using recyclable materials and thinking long and hard about how they construct the vehicle, that is having a knock-on effect for the vehicle recycling industry, and the fact that depollution and that manual task that I keep referring to, that blue section, is actually taking longer because those activities are becoming more intensive. So where we used to do about 1.5 to 2 million vehicles a year, that rate has slowed down significantly because it's a more intensive process now. So for health, safety and environmental professionals, this is just kind of a summary of the hazards that are typically associated with our industry. I'm sure you could hazard a guess at the sort of things that we experience, but the main things to consider here are that all the hazards that you would associate with a typical motor vehicle repair workshop, we have those. The vehicle lifting equipment, the tooling, the pneumatic tools, trailing cables, lots of cutting and grinding outside the desire zones, obviously, because a lot of the components that we see on these vehicles are rusty and need a little bit of persuading before we can remove them. We also do a lot of F-gas recovery and fuel extraction. So we've got flammable liquids, as I talked about before, desire zones, approved tooling. But The thing that's probably most different between salvage repair yards, vehicle recyclers, and a typical motor vehicle repair shop would be the volumes of hazardous materials that we deal with. So you're talking a typical depollution station can be depolluting anything between 25 and 50 vehicles a day. And if that is the case, you can imagine the amount of fuel, flammable liquids, bulk storage of chemicals, oils, greases, lubricants, screen wash, coolant, that has to be bonded on site. Then also you've got your 12-volt bulk battery storage. And then if you think about bringing it right up to date and incorporating electrification, then you've got quarantine areas and storage for large lithium-ion batteries. So there's quite a lot of resources and storage space on a typical modern recycler's yard that encompasses storing these materials until you've got sufficient enough to have it transported off site and reprocessed elsewhere. As I alluded to before, we've also got the pyrotechnic, easy for me to say, pyrotechnic neutralisation, so that is detonating the airbags and the pretensioners. We have all the things that typically would see in the waste industry: vehicle, plant machinery, pedestrian interaction. Yards can be quite congested, and unlike a motor vehicle repair shop, they are traditionally open to the public. So you have a lot of people there whose safety awareness is probably not as good or is not as well developed as those people who are working in the environments day in, day out. All have to be considered. The one thing that I think a lot of people fail to get hold of and understand properly are the environmental challenges and the health and safety challenges associated with improper waste disposal in incoming vehicles. Vehicles are seen as, or can be seen as, a bit of a skip. A lot of recreational drug taking goes on in it. A lot of people live in their vehicles until they are ready for the scrapyard. And that means incoming vehicles can have all sorts of paraphernalia in them. That could be biohazards, sharps, batteries from mobile phones, e-cigarettes. We've seen e-scooters get dumped in there, laptops, phones, vaping sticks that have dropped between the seats. There's bodily fluids. Some of it is not pleasant, but it's a really critical part of why we're seeing health and safety and environmental challenges in the modern vehicle waste industry. Widening things out and looking at our people as well. We have some historic challenges around people. Training has been developed out of work practices that are constantly evolving. As we're alluding to today, and we're talking about the fact that we're trying to make these processes, even though they're very manual, as efficient as possible. We've also got new technologies to have to develop and encompass, and consequently training can be a little bit up and down. So we must also consider the challenge from a safety and environmental perspective does affect recruitment and retention within our industry. My business, ELV Training, is focused primarily on educating our sector and showing us the importance of working to a defined standard, and we believe that that's the main cause around historical difficulties relating to staff retention. Training can be historically inconsistent. We do lose a lot of skilled and experienced people to other automotive sectors. Not that we're doing anything wrong, it's more to do with the fact that maybe development routes are not as clearly defined in our sector as they are in other automotive trades. And that knock-on effect is that the industry lacks them truly skilled and experienced people because they move on to other roles. And that's where inefficiencies in process start to creep in. Shortcuts may be taken, and that environmental and safety risk starts to develop. It's not all dark news. As of mid-2022, we now have got national occupational standards for vehicle dismantling, which is what all our apprenticeships map to, and they share industry best practice. They define a clear performance parameter so that we can provide a consistent work standard and quality assurance for our clients. We also know that has a direct impact on driving efficiency and productivity, and increases safety and compliance. So that's what we work on, is kind of reinforcing the fact that recruitment and retention is expensive, and it also has an impact on environmental and health and safety, and therefore we are critical on getting that recruitment, that training right, and making sure we work to a defined work standard. It will have not escaped any health, safety or environmental professionals' radar that the frequency of fires at scrapyards and waste facilities is on the increase. We do have the second highest fatality rate in the UK, and we have about 300 significant waste fires per year. That's for the whole of the recycling sector. That's not just automotive recycling. Fairness, it's very hard to take the HSE data and drill it down to separate us as a sector. Bearing in mind, we share a lot of relationships with the automotive trade as well. The root cause for many of these fires in waste sites, which are colossal, are the improper disposal of lithium-ion batteries. Lithium-ion batteries are part of our everyday life. They power everything, all our personal devices, all our mobile phones, all our watches, and they are the root causes a lot of the workplace accidents and the fires. We need to ensure that there's a strict adherence in depollution practice. So a lot of the work that the industry is behind, and a lot of the emphasis is really getting on top of this lithium-ion problem, which we were seeing before EVs. We're just seeing it more prevalent now with EVs. So yeah, we need to be more strict around our depollution practice, specifically around technical data when it comes from vehicles and quarantine procedures for EVs. But more to our point, if we don't get our housekeeping right, our incoming vehicle inspections right, then ultimately all we're doing is sending very small lithium-ion batteries into shredders. They get ground to pieces, and then they'll cause a significant fire. The other thing we see is if they get baled for storage, they might not go into a shredder straight away, but that baling process can also damage a lithium-ion battery. And ultimately what happens then, they get buried in stockpiles of metal and waste, and it might be several weeks down the line before that stockpile ignites and causes a significant fire. So lots of investment in regards to heat sensing equipment, and we're making lots of progress, certainly from our training point of view, around vehicle inspection practices and housekeeping. I'm just going to, the caveat underneath that is that insurance companies and the National Fire Chiefs Council have told us that we need to find a solution for this as a sector, and that on no certain terms is this sustainable. We can't carry on like this. We need to sort it. So this is my last slide now, and then I'm going to hand over to Andy, and I thought it'd be nice for me just to kind of dovetail into a little bit of electric. And I would just say we've discussed about ICE vehicles and what current training challenges that we have, and what health and safety challenges we have. I think what we also need to consider now is electric. The challenges around electric are already here, not just in the fact that we're having to incorporate a new vehicle technology, but in the fact that all these improper waste disposal in vehicles is meaning that we already have a significant lithium-ion battery risk. It's going to be a gradual switch over to EVs. Decommission must coexist alongside traditional depollution practice at the moment. I think a lot of people are looking at high voltage training as it's an add-on. It's something we need to train for, and then once we've trained for it, from next Wednesday we can start bringing in vehicles, hybrids, electrics, and we'll know what to do with them. It's not like that. It's a gradual switch over. This decommissioning will need to be thought about in advance. It's going to require significant investment in equipment, obviously high voltage tooling and training. And the industry needs to give itself time for these processes to be truly bedded in. I think it's important also to understand that just like the motor vehicle repair agents, first responders like fire brigade and the recovery industry, breakdown recovery services, we're having to develop our own safe systems of work. We too as an industry need to develop our own operational guidance, and we need time to do that. So people like Andy are absolutely critical to our training well-being, and moving forward it's not just about receiving the training, it's about taking the training and then understanding your planned approach to how you're going to get electric to coexist with traditional internal combustion engine decommissioning. So that's pretty much it for me. I'll be happy to answer some questions at the end, or if you want to forward them via email, you can. You can also visit us at www.elvtraining.com. I'll leave a download link where you'll be able to download today's presentation file. Thank you.
Thank you very much, Mark. That was really, really good. So we're going to leave questions until after Andy's presentation, which is great. And some questions are coming in, and please do ask your questions through the Q&A board. But just a quick reply. Someone's asked, does ELV stand for end-of-life vehicles? Yes, that's correct. So just so we know what we're talking about here. And if you're EVs, I'm sure you already know, is electric.
I think so.
There's lots of E's and V's in our industry, isn't there? Anyway, so thanks very much for that, Mark. That was great. We'll hopefully be speaking to you a bit later on with the questions. And now it's time for Andy Latham from Salvage to talk more. Are you going to be talking more specifically about the electric vehicles themselves, Andy?
Yeah, absolutely. We're going to be talking about electric vehicles, but also some of the risks that come with those vehicles as well. So let me just share the screen, and as that's doing. Okay, so how do we identify that we're dealing with an electric or a hybrid vehicle? How do we know what we're dealing with? Now, with something like this, it's very, very much around badges on the vehicle. We might see a badge on the vehicle. We might see something on the vehicle that tells us it's a hybrid or it's a zero emission. But not every manufacturer is good at badges. Some are better than others. So don't rely on badges. When you look at the instrument pack, you look at the pack of dials in front of you on an electric vehicle, it can be very, very different. If you've got a plug-in vehicle, a plug-in hybrid, or you've got a full electric vehicle, there'll be a plug somewhere. There'll be a socket to plug in. But be aware that could sometimes be under the badge in the grille at the front of the vehicle. But the most important thing you're going to see when you're looking at a high voltage, an electric or hybrid vehicle or plug-in hybrid vehicle, is orange cabling. Now, orange cabling signifies DC voltage in excess of 60 volts DC, 60 volts direct current. Why 60? Well, your skin has a natural resistance of between 50 and 60 volts. Also, an electric shock of anything sort of 70, 90, 110 volts and about half an amp of power is enough to damage your heart, put your heart into ventricular fibrillation. So 60 volts is about the right thing, and every manufacturer follows this guideline nowadays. So you see an orange cable, you know you are dealing with high voltage vehicle. So let's have a look at some safety principles, some hazards and some risks around these vehicles. And everything comes with warning stickers on there. That's just an example. But we can talk about chemical risk. We can talk about electrical risk. We can talk about fire. And we can talk about electromagnetic. So chemical, every battery has an electrolyte in it. If that battery gets damaged, electrolyte may leak from the battery. Lead acid batteries, it's an acid electrolyte. On the high voltage, the nickel metal hydride and the lithium batteries, it's an alkaline electrolyte that could be very, very harmful to health. So if you're dealing with a damaged battery, there might be electrolyte leaking from it. Be aware of that. The biggest risk you find is electric shock. An electric shock will happen when you create a circuit. You may be touching two parts of the vehicle. Electricity could flow through you. Or it might flow from the vehicle to ground, to earth, through you. You make a circuit. It's a risk. Fire. On a damaged vehicle, we can get an arc flash, which is where the electricity jumps a gap. It jumps between 2 points, ignites the air, and if you're close enough, you're going to get damaged. Or actually, the electric vehicle could catch fire. And data that we've seen over the years are showing us that actually these vehicles are very, very unlikely to catch fire compared to conventional vehicles. It's just that if they do catch fire, the consequences can be much more severe. And EV Fire Safe have done data over the last 10 years on global EV fires. And there's not an enormous number of EV fires globally that have been verified. So it is low. Electromagnetic is basically if anybody's got a heart pacemaker, do not work on these vehicles. They create electromagnetic fields when they're operating, so do not work on them. Now, bear in mind, please do not phone up your granddad or your elderly uncle and say you can't drive an electric car because you've got a pacemaker. It is perfectly safe to drive and operate and plug in an electric car if you have a pacemaker. Just don't dive under the bonnet when it's operating. So there's some inherent risks with these vehicles that are very different to conventional vehicles. So how do we stay safe? What do we do? Well, we have a safety kit. There's a whole safety kit that we need. Linesman's gloves or electrician's safety gloves, rubber mat or high voltage overboots, a safety rescue hook, multimeters as well are important. We also need warning signs, barriers or cones. We need safety goggles, and we need some red litmus paper, boric acid or vinegar, and water in the case of a battery electrolyte leak. The linesman's gloves, class 0, 1000 volt minimum, or electrician's safety gloves. These are your prime level of protection. These are what you're going to put your hands in. These are what you're going to put onto the vehicle and work on the vehicle with. It is critical, absolutely critical, that you have a pair of gloves that fit. Not too small, not too big, they fit, they're comfortable. It is also critical that you test and inspect the gloves every time you use them. You visually inspect it, check them for damage, and then you do an air test on them. Make certain that there's no little pinhole in the finger. Fill them up with air and see if they deflate. Critical. Rubber mat or high voltage overboots. You've got lovely yellow boots on the on the picture there. Basically insulate you from ground. Or do what I do, which is I've got dielectric work boots, 1000 volt rated soles, polycarbonate toe caps rather than steel. Much more comfortable for a day walking around the yard. The safety rescue hook. Oh, by the way, with the gloves and the rubber mat or the boots, what we're doing is we're creating resistance. We're creating resistance between us and the potential for electricity. So that's what we're doing. The safety rescue hook, you see one there in the picture in the bottom right-hand corner. Really critical piece of safety equipment that needs to be close to where you're working. Because if somebody gets an electric shock, their muscles are going to contract. Their hand will lock. They cannot let go. One of their colleagues comes in beside them with the hook around their arm and separates them from the source of that electric shock. The lifesaver. Everybody in the business needs to know what that is, why it's there, and how to use it. We use a multimeter because we want to test the vehicle to confirm shutdown. Warning signs, we put warning signs on the vehicle. Ideally, when we're working on the vehicle, we put a barrier, a cordon around it to keep the unqualified out. Safety goggles protect our eyes. We've got two eyes, let's keep it that way. So use safety goggles. And then the litmus paper, the boric acid or vinegar is what you use if you think you have a leaking battery and you want to test what's leaking and make certain that it is or isn't an alkaline solution. If the gloves are our first level of protection and our boots or what we're wearing on our feet is our second level of protection, our third level of protection is what we're holding in our hands. High voltage tools. 1000-volt rated, insulated, high voltage tools. If you've ever seen a conventional spanner short out across a 12-volt battery, you'll know how powerful that is. You imagine an 800-volt battery doing the same. So absolutely critical that you have high voltage tools as well. Now, there is a process around doing these vehicles, around dealing with these vehicles. And the number one thing we put in that process is do your research, because there is no common practice. Manufacturers are different. So do your research, because what you do for a Toyota is very, very different to what you do for a BMW. And the second line we put in there is always follow manufacturer guidelines. Really, really critical that you follow the guidelines that the manufacturer has given. What's happened to the vehicle? Why is it coming to you? Why is it coming into your business? Be it your repair shop, your collision shop, your recovery yard, your salvage yard, wherever. Why is it coming to you? What's happened? Is it an accident? Is it a fire? Is it a flood? If it's a flood damaged vehicle, you treat it very, very differently to if it's an accident damaged vehicle. If water's got inside the battery, then the fire risk has just gone stratospheric. You put it outside, you put a cordon around it, leave it there for at least 24 hours and see what happens. Could be a fire accident. Has the battery been compromised as a result of the accident? You've got a fire risk, an electric shock risk, or possibly even a chemical risk from leaking electrolyte. You check your safety kit and your personal protective equipment. You do a walk around the vehicle. You're not touching the vehicle. You're now doing a dynamic risk assessment as you walk around the vehicle and examine it. You're doing this in a dry, a well-lit, a well-ventilated area. You do not want to be doing this outside when it's pouring down with rain. You prepare and utilize the vehicle. You shut down the vehicle. You switch it off. You shut down the high voltage system. We then test it. We lock it out. And we update the signs. The first set of signs are saying danger. The second set of signs are saying we've now made it safe. And then we commence the work on the vehicle. Now, the sort of process that we follow can be very, very different. There's a generic process here, but this won't work for every manufacturer. So always follow manufacturer process. But we switch the vehicle off. We remove the key, lock it out. We disconnect the 12-volt battery. That's all low voltage. We then put on our high voltage personal protective equipment. We then remove the high voltage link, the manual service disconnect, if you want to call it that, or as we call it, the big orange plug. You leave the vehicle for 10 minutes. You're allowing capacitors, which are an integral part of the system, to discharge. And then you test with the multimeter at the point that the manufacturer specified to confirm zero voltage, to confirm that there's no voltage left in the system. And then you mark the vehicle to show that it's been shut down. Now, what you might find, and we've got a picture there with orange plugs on it, but you might find slight differences. Early Hondas had a rocker switch. So the Honda Civic Hybrid, the early one, Honda CRZ, and the Insight had a rocker switch. Some new vehicles, Mercedes, BMW, Volkswagen Group, now Stellantis, so that's Peugeot, Citroën, Vauxhall, Fiat, and so on, have a little green and black plug that does the job. Why we say follow manufacturer recommendations, because they are all different. But once you've made it safe, you can now then work on the vehicle. In a depollution, a vehicle depollution and a vehicle dismantling facility, we're looking at those batteries because we're looking at what we call the 4 Rs. What can we do with those batteries? Can we reuse them? Can we sell them and put them back in another vehicle? Can we remanufacture them? There might be a fault on the vehicle or on the battery that we've identified, so we can take it out of the vehicle, strip it, and replace some components inside the battery to make it a good one. It then goes into reuse. Can we repurpose it, put it into another application? It might well be an application for static storage. These batteries are lasting the lifetime of the vehicle, and they're lasting the lifetime of the vehicle, and they've then got a number of years of use as static storage. And that could be 25, 30, 40, 50 years of static storage before they then go to the bottom of the pile, the last resort, which is recycling. Data that came from a company called Rejoule in the USA earlier this year was that on the batteries that they are recycling at the request of various companies, over 90% of those batteries were 92% efficient, which meant that they were perfectly usable in another vehicle, back in another vehicle. Recycling them early is a waste of resource. So recycling is the bottom of the pile for deliberate reasons. And what we do say is that every battery in the vehicle must be recycled. And in some cases now, in new vehicles, in vehicles over the last 10 years, we have got multiple batteries. Batteries in GPS sensors, emergency call systems, tire pressure sensors, keys, alarm systems, and much, much more. The picture you see there, the top one is a good battery for the emergency call system on the vehicle, and the battery backup for that. Below it is one that was left in the vehicle when the vehicle went through the crusher and it exploded. That was left in the vehicle. Everything should be removed. Every battery should be removed from the vehicle. Now, if a battery does catch fire, or an electric vehicle does catch fire, then we've got all sorts of issues around this. The fire services are telling us that they need 10,000 litres of water in 1 hour. The reason they need that is they need to put the fire out. They need to bring the temperature of the battery down so it doesn't reignite. The average fire truck carries about 12 to 1,400 litres. So to get 10,000 litres is a pump and a hydrant. By the time the fire services have got that sorted out, your building's now a total loss. You might now be into a major incident. So what we say is have a look at the vehicle fire blanket. The vehicle fire blanket is fast, it's effective, it's very simple to use, it's very eco-friendly because you don't need 10,000 litres of water. And if you buy the right one, you can get a single-use blanket. If you buy a multi-use blanket, then the multi-use blanket can do up to 30 fires. I think if you've had 30 fires, you've got more of a problem. So, look at that. If you're working on electric vehicles and you're doing a lot of them, then have a look at the vehicle fire blanket. By the way, the fire blanket will work on conventional vehicles as well. It's not just electric vehicles that works on. So, giving you a quick snapshot, and we've left sort of 15 minutes or so in time for questions and answers. But there's a whole host of resources there, which obviously we'll make available to various, to everybody on the webinar. We've also got a discount code for you if you want to buy tools and personal protective equipment for electric and hybrid vehicles. then if you go to eintac.com, EINTAC.com, and you use the discount code ES Echo Sierra 10, then there's 10% off for you on that. And we also do a lot of additional training. We work for IMI accredited training. We deliver City and Guilds accredited training, and also to Rhineland as well, accredited training. So if anybody wants to know more about that, then let me know, and we can sort that one out for you. So that's me very quickly done. Haydn, I'll stop the share and I'll pass it across to you, and you can go through the Q&A.
Yeah, thanks, Andy. That was great. And lots of replies there. People sort of obviously understanding there's more to it than meets the eye. Oh, and thank you. Well, you're back, Mark, which is great. I was going to introduce you back. Let's get onto the questions which we've had come through. One of the things, let's go back to you, Mark, is you was mentioning airbags. Can you just go over about how airbags are deployed, talking about what gases are released and what protections there? There's some interest there.
Yeah, it's one of the very first parts of the depollution process. As I said, it happens outside of the desire zones where we extract the fuels for quite obvious reasons. From a ventilation point of view, that's why there's a preference to obviously do it outside. If they do it internally, and some larger operations do it internally, it's usually under forced extraction, so they've got some sort of fume extraction process involved. Usually crack open a window and kind of put the ducting into there, and that'll draw out the fumes. Also, cracking the windows open during that depollution, during that airbag detonation process, that basically stops the force of blowing out maybe the sunroof or one of the windows, because obviously it's quite an explosive force. Doesn't detonate all the airbags together, does it in a series. What it is a small handheld device referenced as a blast box. You connect that, you send a power source directly to the SRS module, the control module relating to the airbags, and it will in turn fire them and detonate them remotely. So you activate them from a handheld device, but you're meters away from when the detonator goes off. Yet, as much as there's a lot of questions around whether or not you should be breathing in the materials that come from airbags and stuff like that. So we steer away from that completely. All the equipment has been designed to obviously to separate the user from the actual detonation event. So obviously it's distance. That's how that risk is managed. Or as I said, if it does happen inside, those it's been extracted. There are other devices as well that depollution specialists use, which will be sound deadening material, matting, or a hood or a jacket that sits over the car to obviously catch any sort of flying debris that might be there, because certain vehicles that have been involved in collisions may not necessarily have had the pyrotechnics detonated in that event, and consequently if we need to go in there but there are already shattered laminate glass and bits and pieces, then it's important that we protect that immediate area from any materials being discharged.
Yeah, no, thanks, Mike. Returning back to electric vehicles, Martin Brady's asked, Andy is saying that it's likely that an EV battery will have a fire. But Marky was sort of saying that we are seeing more fires in salvage yards. I think there's a bit of confusion here, because I think sort of Andy's talking about the practicalities of an electric vehicle, whereas Mark, you're talking, and I'm sure your answer will be towards volume and processes to make sure that these fires don't occur. So can you just sort of clear that up between both of you to what you're saying?
Yeah, I mean, from my experience, yes, a properly managed electric vehicles are safer. Right? They are less likely to catch fire than a conventional vehicle, and we've got evidence, factual-based evidence that supports that. Obviously, what Mark said was that in a yard, salvage yard or whatever, you've got many other instances. You've got so much other stuff coming in, which may well create a problem. Not necessarily the electric vehicle that would cause that problem, but as he said, cars are used as skips. They're used as dumping grounds. And we do regularly get cars coming in as end of life that are full of all sorts of stuff, that people just want to dispose of. And that could include batteries.
Do you want to add to that, Mark?
I think you offered me a robust defence there, Andy. Don't get me wrong, I'm absolutely pro EV. I can't afford one yet, but yeah, I'd like to run one day. I absolutely welcome the advancements of EV, and I'm sure the technology won't stop there. Yes, what we're trying to understand is that these two technologies, internal combustion engines, need to sit alongside electric vehicles and hybrids. And consequently, what I was trying to explain was the fact that these activities need to coexist. So we need to make sure we're not doing something entirely different for electric that we are doing for depollution. Otherwise, inherently, what we're going to do is build inefficiencies into what we've already defined as quite a manual process anyway. But obviously, that is all around making sure that we understand the challenges around electric in relation rather than in isolation to internal combustion engines. And what I was the reference I'm making as far as lithium ion is concerned is even before a metal recycling yard or a vehicle salvage yard has considered the risks associated with introducing electrical depollution into their dismantling processes, they already are having to address the challenges relating to improper disposal of lithium ion waste coming into the existing internal combustion engine vehicles, and that in the past we didn't have the batteries there, and because we didn't have the batteries there, they could go into the shredder and it wouldn't be a problem. But now the batteries are there, we need to make sure that we really tighten up those incoming monitoring and that housekeeping that we're doing right when we first receive that vehicle, to make sure that we've stripped it and we know there's nothing in there that's going to have a challenge to the automated processes later on in the dismantling process.
Thanks, Mark. Now, Vincent Howes, he's got a good question. He says, can you advise on the best way to store a damaged lithium-ion battery from an ELV? Now, this goes a bit further because sometimes we don't even know the vehicle might be in an accident, but we don't know what the state of the battery is because it's been cased up. There's a lot of protection around that battery. That's why electric vehicles are so heavy. So what are the complications that go with that before we even look at how we do store that damaged battery?
A lot of it, I'll be honest, a lot of it is that first assessment of the vehicle and that first check of the vehicle. And if you feel that you've got a battery that's been compromised, then you get the vehicle out in the yard. The manufacturers actually recommend that you store it, if it's in the vehicle and you think you've got a damaged battery, you store it with an exclusion zone around it. And that exclusion zone varies from 5 meters to 15 meters, depends on the manufacturer. There's a lot of yards out there that do not have that space and do not have that space to do that and to store them. The reason they say that is that if the vehicle is compromised and it does catch fire, then it's not going to take anything else with it. But what we've actually found is that you can store it, put the fire blanket over it, and the fire blanket becomes the exclusion zone. So if the vehicle does catch fire at 9 o'clock at night, it's contained underneath the fire blanket. If the battery's out of the vehicle, we recommend a number of things, which is number one, store it in a suitable container outside, away from the building. It's a sacrificial container. So if it does catch fire, you just let the container burn and let it go. Don't store it in a warehouse because you can have problems. Don't mix the battery chemistry. We've got nickel metal hydride and we've got lithium. They don't like each other. So, you can put them in the same container, but have a gangway between them. Don't put them on the same shelf or on one shelf above the other, because if something goes wrong, they don't like each other. Restrict the access, so only trained people go into that area, and also keep them dry as well, because if they get water inside the battery, then you've got a major problem. So that's the sort of advice that we're getting nowadays from vehicle manufacturers. And you can buy a specific battery storage device, battery storage container that you can put out in your yard. If you've got 40 grand spare to spend on that, then by all means go and do it. Not a problem. But a lot of other people that we know have just gone and got a container, racked it out, put it somewhere in the bottom of the yard. So if it does catch fire, it's not a problem.
Do you have anything to add to that, Mark?
Yeah, he's done a really good job. All I'd say is that the prevalence of handheld heat sensing technology, your infrared cameras and stuff like that, as the cost is driving down on useful tools like that, they are becoming invaluable in not just in vehicle recycling yards, but just maintenance on vehicles, checking where there's worn parts, defective equipment. That they're a great tool for trying to understand what's going on inside as far as the battery chemistry is concerned. What's going on, whether or not there is some sort of short circuit, or whether or not a battery component is going to go into thermal runaway and stuff like that. So yeah, technology is coming up with a lot of the answers for us, but Andy's absolutely right. To accommodate this properly and do it in good volumes, we need to consider the fact that space is a premium in these yards, and our smaller yards may struggle to offer this.
Okay, and very quickly, because I'm sure we're aware of time. Andy, Paul Giles asks, can you use the GHS symbol for corrosive? The orange corrosive is the old pre-2015 classification. Do you know if there's...
Yep, it's fine. Yep, good feedback. Thank you.
There you go, Paul. It's fine. How much longer have we got? I haven't been really keeping a time. I know we can go on forever when us three get together. Nothing? Okay. So just carry on.
I've got, according to the timer.
What have you got, Mark?
I've got 1 minute according to the timer to take us to 1:30.
Okay, well, let's do this question because it's a great question and you've got 30 seconds each to answer it. If you have the chance to influence the manufacturer, which material installation would you recommend to eliminate or substitute and that are considered extremely hazardous to your operation or the environment? 20 seconds each. Go for it. What advice would you give to a manufacturer? What would you like to say to a manufacturer?
Quickfire. I've never been good at quickfire rounds. Anything that takes the fuel out of it, a flammable liquid out of it. So moving away from the internal combustion engine to a lot more low maintenance. I think that has got the most to gain.
Andy?
Yeah, it's a difficult one, is that, because we're looking at the waste hierarchy there, and we can't eliminate high voltage, we can't eliminate fuel, we can't eliminate oil at the moment, because these are the way the cars that we are getting are designed. And the problem that we have is that we have politicians giving us targets and legislation, and the only way we've got right now of achieving that zero emission target right now is either fully electric or possibly hydrogen, and hydrogen brings its own new level of risk and hazards along with electricity.
Okay, thanks, Andy. So I think we're drawing to an end. Thank you very much, gentlemen, for providing such excellent information. I hope for the people who are watching today that you've learned a lot, but at the same time, it's pricked up your ears to be thinking about what else there is involved. We still have a long journey to go on this subject, I'm sure. If you want to keep up to date with what's going on within vehicle recycling, just check out autorecyclingworld.com or atfpro.co.uk. And also, just say if you are interested, I'm also helping an organisation called the IRT, which is the International Roundtable on Auto Recycling. And on the 2nd of May, we have a conference on the value of electric vehicles when it comes to recycling. If you go to their website, you can join that. That's another free webinar. So keep up to date. And also, if you're in the UK, we have the Vehicle Recycling conference happening on the 9th of May at the British Motor Museum. Again, you can find information about that on the atfpro.co.uk site. So thank you very much. I don't know how the IOSH ends these sessions. I don't know if we all have a song or a sing song or something like that. I don't know what the protocol is. So Akrim, are you there to sort of take over and just say farewells and just give some closing statements? That would be great. Thank you very much for your time. Thank you very much for attending. I hope you've learned a lot. Thank you very much, Mark. Thank you very much, Andy.
Thank you.
Thank you very much, Liam, Akrim, for sort of putting this all together. And hopefully we'll be in touch soon. Get in touch with Mark and Andy. You've got their web pages and sites to find out more information. These guys really know what they're talking about. Thank you very much and goodbye.
Goodbye all.